In this video, we will go over the strategy to tighten the screws to secure a PCB to its housing. Keep in mind that it is very important to ensure that the workpiece is correctly positioned and secured before starting this operation. Let's start by looking at a simplified pseudocode for tightening the first screw. The same approach will work for all the other screw positions. Later, we will see how to complete it by adding an error handling sequence. We will slow down the simulation and watch it one more time while highlighting the corresponding pseudocode instructions. To teach the positions of the robot, we will follow a similar strategy discussed on the previous Picking Up Screws video. We will extend the shank, manually attach a screw to the bit, and then use it as a guide to teach the tightening position. After aligning the screw, we will retract the shank a small distance so that the screw can be fully tightened before the shank reaches its maximum extension. We will readjust the screwdriver's height and then teach the tightening and approach positions. The OnRobot screwdriver handles everything needed to successfully perform a tightening operation. We just need to set the torque and screw length directly on the robot's interface, and the screwdriver will automatically extend the shank, rotate the screw, and monitor the tightening parameters to ensure the quality and consistency of the assembly. It is highly recommended to use the screwdriver's feedback to validate the process, check for errors, and to keep a record of the tightening parameters to ensure conformity between all the workpieces. The OnRobot screwdriver not only monitors the final tightening torque, but has many embedded sensors and monitoring algorithms that can detect issues during tightening operations. Let's take a closer look at some of the common tightening results. We will start by showing a successful tightening operation. When cross-threading occurs, the rotating screw will create additional resistance, which will cause the target torque to be reached before the screw is fully seated. When using longer screws, or there are assembly components missing, like the part or a washer, the screwdriver reaches the screwing length, but not the expected target torque. When using shorter screws, or there are extra assembly components, the target torque will be reached before the expected screwing length. A missing screw will either create a timeout error, or the screwing length will be reached before the target torque. The OnRobot screwdriver can be easily configured to perform a tightening operation and monitor the quality of the process.